Alright, let's go through this. Bill had a full hip replacement last week and was prescribed antibiotics. Those killed off the competition in his gut, and now he has a raging C. diff infection, including cramping, vomiting, and diarrhea. Also to note is that he has intense pain. The vomiting and diarrhea will cause dehydration. Dehydration will lower the ratio of water to solutes in his blood, thus increasing his BCOP. Remember, BCOP is the amount of pressure that water wants to enter the blood vessel because of the solutes in the blood vessel. In this case, we're taking away water and thus increasing that ratio. He also has intense pain. Intense pain can trigger a sympathetic response and increase his heart rate. This is an interesting problem because heart rate increasing will increase hydrostatic pressure and try to increase filtration. BCOP, however, will try to decrease filtration. So we're going to have to use clues from the question and the answers to solve it. First off, a blood pressure increase. BCOP doesn't affect blood pressure, so we're going to be looking at our heart rate going up. A blood pressure increase will cause myogenic constriction of renal afferent arterioles. There are stretch receptors on the afferent arterioles that when blood pressure increases, it will cause constriction, and this is myogenic. And so the first one is right. The second one, the only difference is the efferent arterioles. If there were stretch receptors that activated on the efferent arterioles, then that would back up the blood into Bowman's capsule and increase hydrostatic pressure further, which would be a positive feedback loop. And that's really bad. So we're going to say that's wrong. Number 3, an increase in BCOP will raise his GFR. Well, we just said an increasing BCOP will lower filtration rate and not raise it. Now on 4 and 5, we are looking at the macula densa cells. The macula densa cells pick up sodium and calcium ions in the tubules and use those to regulate the hydrostatic pressure. In this case, we could have the filtration rate going up or down based on how strong the BCOP and heart rate are affecting the system. But let's look at the answers and see if there's issues. The macula densa cells will release nitric oxide onto the efferent arterioles. The nitric oxide relaxes the arterioles. If we relax the efferent arterioles, then we are increasing blood flow out and decreasing hydrostatic pressure. It could do that in response to the increased heart rate. So I'm going to check that. The macula densa cells will release norepinephrine onto the efferent arterioles. If norepinephrine is not used by the macula densa cells. Norepinephrine is actually used by the nervous system to constrict the efferent arterioles if the blood pressure is too low and the kidneys are not enough to fix it alone. And so the correct answer here is B.